Alright, I'm definitely having fun now. Next lesson, section 10-4. All students will be able to solve problems and prove statements involving inscribed angles. So let's talk about what an inscribed angle is. If I draw the circle and I draw an angle such that the vertex of the angle is on the circle, then this is an inscribed angle. So what we'll say is angle ABC. Oh, let's try to erase that. Big money, good, good, good. Alright, so angle ABC is an inscribed angle because its vertex, point B, lies on the circle. Make sure you understand the difference between an inscribed angle and a central angle. Notice that the inscribed angle intercepts an arc. It intercepts a minor arc AC, and it also intercepts major arc ABC. So you might be thinking, is there a relationship between the measure of the inscribed angle and the measure of its intercepted arc? And for purposes of what we're talking about here, I'm going to talk about the minor. Well, that relationship is going to be theorem 10-5, which is going to be called the inscribed angle theorem. In your homework book, it is homework theorem 9-7. And it states that the measure of an inscribed angle is equal to the measure of its intercepted arc. The measure of an inscribed angle is equal to the measure of its intercepted arc. So in this angle, in this circle, here's angle ABC. What we're saying is the measure of angle ABC is equal to 1/2 the measure of arc AC. Remember that the measure of an arc is measured in degrees. So if the measure of arc AC is 60 degrees, then the measure of angle ABC is going to be 30 degrees. Let me outline the proof. Really, if we're going to look at this, there are really a couple of cases we need to look at. And when I say a couple, I mean 3. If I'm looking at this circle and this angle is angle ABC, there are 3 possibilities that might occur. Maybe point O lies on one of the segments. It lies on angle ABC. Maybe point O, the center of the circle, lies inside angle ABC, or maybe point O lies outside angle ABC. What I'm going to do is I'm going to outline the steps of proving the first case to you, that point O lies on angle ABC, and then the other 2 follow from that. So what we'll do is let's draw this radius OA. And I'm going to let the measure of angle ABC, I'm going to let it be x. Well, since the radii of a circle are congruent, that means segment OA is congruent to segment OB. In this isosceles triangle, the base angles are going to be congruent, so the measure of angle A is also going to be x degrees. Yep, that's an x. Therefore, we can conclude that the measure of angle AOC is going to be 2x degrees. Remember that if I draw the exterior angle of a triangle, if I draw the exterior angle of triangle AOB, so the exterior angle is going to be AOC, the sum of the two remote interior angles is the measure of that exterior angle. So the measure of angle A plus the measure of angle B is the measure of angle AOC. X plus x is 2x. Therefore, since the measure of angle AOC is 2x, the measure of arc AC is also going to be 2x, because that's the measure of its central angle. Therefore, we can see that the measure of angle ABO is 1/2 the measure of arc AC. That is, x is equal to 1/2 of 2x. And you might imagine how we could use that to prove the other two cases, when point O lies inside angle ABC and when point O lies outside angle ABC. Okay, let's give a couple quick theorems / corollaries. The first one is going to be theorem 10-6, which our homework book calls a corollary. They call it a corollary of the inscribed angle theorem. It states that if two inscribed angles intercept the same arc, then the angles are congruent. So here's my circle. Here's one inscribed angle. Here's another inscribed angle. Notice that those two inscribed angles both intercept the same arc. Let's say the blue angle is angle ABC and the red angle is angle ADC. Well, what we can therefore conclude is that angle ABC is congruent to angle ADC, which makes sense. If their intercepted arc is arc AC, and each of them has a measure that's 1/2 that of the intercepted arc, therefore it makes sense they're going to have the same measure, angles B and D. That is, they're going to be congruent. Next one, theorem 10-7. This is homework corollary number 2. Which states an angle inscribed in a semicircle is a right angle. An angle inscribed in a semicircle is a right angle. This is a very famous one. This shows up on the SATs every year. Let's say we have this semicircle, AOC, and we have angle ABC inscribed in that angle. In that semicircle. Remember, the semicircle is formed by the diameter. Therefore, this must be a right angle. Since AC is the diameter, the measure of arc AC is going to be 180 degrees. Therefore, the measure of angle ABC is going to be half of that, or 90 degrees. Next one, Theorem 10.8. I'd rather write this in blue. Alright, hopefully I didn't mess this up. I think I should be on Theorem 10.8. Again, let's write that in black. This is homework corollary 3. I'm trying to write neat. I'm trying. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. For example, let's say that we have this circle, and in this circle I'm going to inscribe this quadrilateral. Quadrilateral A, B, C, D. What we're saying is that opposite angles are supplementary. The measure of angle A plus the measure of angle C is 180 degrees. The measure of angle B plus the measure of angle D is 180 degrees. Let me show you why that's going to be true. Let's take a look at angle A first. So that would be angle BAD. BAD. Notice that the intercepted arc of that angle is going to be arc BCD. That's the intercepted arc. Also notice when you take a look at angle C, that is angle DCB, its intercepted arc is arc DAB. Well, combined, those two arcs give me the entire circle. So, if I know that angle A is 1/2 the measure of arc BCD, and I know that angle C is 1/2 the measure of arc DAB, that means that the two angles added up must be 1/2 of 360 degrees, or 180 degrees. And you can show that similarly with angles B and D. Alright, last theorem for today. This is not in your textbook. This is homework theorem 9-8. The measure of an angle formed by a chord and a tangent is equal to half the measure of the intercepted arc. The measure of an angle formed by a chord and a tangent is equal to half the measure of the intercepted arc. Here's my circle. Here's a chord. Let's call that chord AT. And we have a tangent. Let's call that segment TP. That's supposed to be tangent to the circle. So there's my point of intersection right there. What we're saying is if the measure of arc AT is 140 degrees, the measure of arc AT is 140 degrees, then the measure of angle ATP is equal to 1/2 the measure of arc AT. That is 1/2 of 140 degrees, or 70 degrees. Okay? That wraps it up for that lesson. Keep working through those classwork problems. If you have any questions, you know the drill. Work with the people around you. You can drop me an email, and we'll go from there. Okay? Talk to you later. Bye. In blue. Oops. Let's go back. Well, I think I might have messed. Oh, hold on.